You may come across a situation where you have to deal with large data files. The one that's on the screen is a fairly large data file, and I'm going to explain it, but it's really huge, and in fact, it doesn't all fit. This data file has over 10,000 lines in it, so it's a pretty big data file. And we're going to use it in this example. So this will be a case study where we're going to deal with a file that contains quite a bit of data. Now, let's look very carefully at this data file. At the very top, there are some column headers, which indicate what each column is. So on the far left side, we have something called the station. Then we have the station name that goes all the way over to here. And then we have the date followed by some geophysical parameters. This is actual climate data that I got from the center, the National Climate Data Center in Asheville, North Carolina. And it's available for free, and you can get it for any part of the country for a wide range of years. So some of these columns across here, you can tell what they are. That's going to be a precipitation. This is going to be the amount of snow. There's a maximum temperature, a minimum temperature, and then there's a wind column way over here on the far right. So this is the data file that we'll be using. So the first line has the column headers. The second line has underscores or dashes below the headers. And then the third line and beyond, we have actual data from stations. Let's look at those a little bit further. On the far left, that's some kind of station ID. So these are weather stations. These are ground-based weather stations, and each one has its own unique identifier. And these weather stations are located all around the states. This one and this entire file is going to be for Alabama in the United States. The station name is going to vary, as you can tell. In this case, we have the name of the location and a number to go with it. And as we scroll down, you'll see that there are different names for these different locations. Here's one at the Bankhead Lock and Dam, and here's one in Dadeville. But what I really want you to notice here is that this column really changes. The number of words that you have for the station name is going to change, plus these notations with the numbers, those are going to change too. So these are going to change quite a bit as we go from one record to the next. Everything else is at least formatted consistently. The date is shown here, and this is the year part of it, 2018. The month is March, and then you'll see we have the dates 1, 2, 3, and so on. So we have all of the data from this weather station for the month of March, and the last one here is March the 31st. Then we have all the data for the next station. It begins at March 1st, and it goes all the way to March 31st. And this continues all the way through the file for every one of the weather stations that we have. Now, if you look at these geophysical parameters, you'll see a lot of them have a negative 99.99. And those are flags. So that negative 99.99 doesn't mean anything physical. Like the temperature, negative 99.99, well, that's not a reasonable temperature for the maximum or the minimum. So whenever you see these negative 99.99 numbers, that is an indicator that the data was bad on that particular day for that particular instrument, or there was no data taken by that instrument at that location for these geophysical parameters. So that explains the file, and I want you again to notice that the length of these columns is exactly the same. Okay, they are all consistent. The date's always the same number, and these geophysical parameters are always the same width. So that will help us because we are going to read in all of this data, and we're going to do some processing with it. So after explaining the format for the data file, then I want to give us and you a challenge. So here is your job. Here's our job to accomplish with this program. What we want to do is we want to remove any data records that have bad data for the temperature max and the temperature min. So we could assume that we're working for someone and they have given us this task. Here's a data file, but I only want to see records that have good data for the temperature max and the temperature min. So we need to write a program that will detect the max and the min temperatures and test to see if they're 99.99. And if they are, we want to reject that record from the new file that we'll be creating. So as we go through this, we're going to find good values for Tmax and Tmin, and when we do, we want to write that out to a brand new file. So we're filtering this large data file into a much smaller data file. So that's the objective of this program. So here is our beginning C++ code. So this program is going to read and process the weather station data. So we're going to input one full line at a time. Let's highlight that. And then we're going to process it using our string manipulation functions. So we have seen some of these already. So we're going to use the following features here. We have our opening file, and we have our manipulators. So we have the file open, we have the fstream, the read, the close, all those things. And we're going to use these input operations, or string processing operations, where we'll have the substring, at, length, find, and maybe some others. And in order to read in the data, we're going to use getLine. And remember, when you use getLine, it reads in an entire line of information and it stores it in a string. So each one of these records in the data file is terminated by an end-of-line character, so we can use getLine in order to input the data. We have the usual stuff at the beginning of the program. I have a couple of string variables that I'm going to use, and I'm really only going to use the data line string variable for this particular program. And this one, station, I don't think I'm going to use that one. And now we have some unsigned integers. If we want to read in the information from these data records, then we need to know the positions so that we can use our substring feature. So in this case, what we really need to get is the position of that maximum temperature column and the position of the minimum temperature column. So I'm going to use those two, and again, I'm not going to use these until a later program. When we bring in the temperatures, Tmax and Tmin, then they're going to be part of a string, and we'll have to use a substring in order to pull those out and convert them. So I have a Tmax value and a Tmin value, which are going to be a type float. So we'll need to extract the string versions of Tmax and Tmin, and we'll need to convert those to a floating type. So I've got variables, so I have variables for those. Now the final information is what we've seen already. We have to have the usual stuff here to read in the files and to test to make sure that they are read in correctly. One thing I notice here is that I am using the data folder, not the temp folder. So I want to change that. And I am using a file called alabama_weatherstation.txt. So that's the file that I just showed you with those 10,000 or so records. And you'll be able to download this. Just refer to the notes that go along with this video, and I'll give you the link to download that file. We're going to create a new file, and it's going to be called filtered alweatherstation.txt, and it's also going to be placed in the data folder on my Windows workstation. Now let's move down and let's get into this. We need to read in the data, but as I showed you with the file, the first line is just going to have the names of the headers. It's not going to have real data. And then the second line is just going to be that line of underscores, those dashes. Okay, so let's look at that one more time. So you can see that the first line is the column headers, the second line is the dashes. But we can use our find method that you have seen already, and this first line, and we can look for Tmax with the find, and we can look for Tmin. So we don't have to spend a lot of time counting over to see where this column begins. We can use the find method, and we can locate the column and it will return the position. So that's what I'm going to do with this first line from the file. Then the second line, I'm going to read it and write it out, but I don't need to do anything else with it. So let's begin. Let's put the code in here to read the first line. So we'll use getLine. The file pointer is in file, and I'm saving that entire line in this variable called dataLine. When you're beginning a program like this, it's always a good idea to write the output to the screen so that you can see immediately whether things are working or not. So I am going to write the line out to the screen as well as writing it out to my new out file. Okay, so I'll read in the line and I'll write it to the output file, and then I'm going to write it to the screen. So that will tell us that our program's working okay if we see some real output there. Now, before we read the second line, what we want to do is we want to utilize the information in that first line to find the column positions for Tmax and Tmin. So we're going to use what we've already learned in our string processing methods. So let's paste this in, and we're going to use the headers, that is that first line, to find the position of the max and the min temperature columns. So to do that, dataLine is the string, find is our method to look for a substring, and the substring that we're looking for is this uppercase Tmax. So when we find that, we're going to save that position in the variable position underscore Tmax. Now, as you recall from when we were looking at the find operation, you must always check to see if you really found something or not, because if it didn't find it, then everything else in your program isn't going to work. So we need to put in our if statement to verify that we did indeed find the Tmax column. So let's paste in that if statement. So we will use, if we don't find the Tmax, then the position Tmax is going to be that really huge integer value that's like 4 billion something. So if we get a position that is less than or equal to the length of that line, then we know we found it. If we found it, let's print out the column. So we will find Tmax, and we will print out that Tmax begins at column, and we'll see the column. So again, that just helps us to know that our program is working correctly. Okay, so if we made a mistake, if we had a typo or something, then we didn't find it, we'll print out this error message, and then we'll just stop the program at that point. So that's what you should always do when you do a find. Now, if we did find it, then we can proceed. Then we need to find where the Tmin column is, because we want to use substring coming up. So that's what I'm preparing for here. We want to use substring shortly. So now let's locate the column position for Tmin. So the code that we need to do that is almost identical for the Tmax. So we want to use our data line, and we want to search for the string uppercase Tmin, and when we find it, we want to save that position. Then we have the if statement here to test to make sure that we really did find it. Now, we have recorded the position for Tmin and the position for Tmax. We'll use those shortly in order to extract the data from those columns. Now, moving along, we want to read the second line from the data file. The second line is just those dashes. We can't do anything with it, but we want to write that to the output file, so the filtered output file will look very similar, as far as the headers are concerned. So let's just put the lines of code we need to do that right here. So we paste that in, and we do a get line that reads in the second line, which is the dashes. I'm going to print that out to the out file, and also I'm going to write it out to the screen. So this will then prove to me that I'm reading in the data okay from the file. Now, once we've done that, we're ready to go through a while loop, and that will allow us to read in and process all of the data lines. These first two lines, those don't have any data. But all of these that we put here, or the code we put in here, is going to process all of those data files. But before we go any further, it would be a good idea to compile and run this program to see if all of the stuff that we've just done works. I'm just going to add the system pause statement here, so the program will stop at this point. We have nothing else going on anyway. So let's verify that what we've done already really does work. Let's verify that we can open and read from the file. Okay, now we have the output. And we do have stuff on the screen, which is promising. So this says the data file is open to read. The output file was open. That's good. Then we have read in and printed to the screen the first line. So we have word wrap going on here since it's such a long one, but that's the first line. Then using that first line, we have detected the column for Tmax and the column for Tmin. Then we read the second line from the file, and here line 2 is just all those dashes. So far so good. We've been able to open the file and read it. So that's a big step that we've completed. All right, so now let's go back to the code. And we want to start processing the data at this point. So I can take this system pause out because now I've proved that the program does what I want up to this point. Now, let's start processing the data. So you can see the while loop is going to continue until we reach the very end of the file. So let's put some lines in here of C++ code so we can read the data lines. So we do a get line, of course. So this reads in the first line of data and all the other lines of data. Now our purpose, remember, is to filter out all of the lines that have bad temperature data, the Tmax, Tmin, all those lines that have a negative 99.99. We don't want those. We want to filter those out and just keep the ones that have good data. We know now that we have to get the Tmax and Tmin values in order to test them. So let's look at how we can use our substring in order to extract the Tmax and Tmin from the line data line. So let's paste in the code to do that. So we want to extract the Tmax and Tmin values from data line, and we can use substring for that. So I have a couple of string variables. Okay, Tmax underscore S, that's a string type. Tmin underscore S, that's a string. And that's we have to do that because the substring method extracts from a string and delivers a string, so we need to capture that as a string. Okay, so data line is a string, and we do our substring. The substring takes the position and the number of characters that we need. So we know the position Tmax because we found it up above, and we know the position of Tmin. So our program actually found those when we did the find operation. Okay, so we printed those out. Okay, one's 123, one's 132, I think. So we'll use that, and if you count how many characters we need, then there are 5 characters for the Tmax column and 5 characters for the Tmin column. So these two lines then will do our substring operation, and it will pull out the Tmax and Tmin values, saving them as string types. Now let's convert those to a float before we do our if test. So let's paste in the code to do that. So we will convert these two strings to some floating types. Okay, so to do that, then we have a special function that's built into C++ that allows us to convert things from strings to different types. So this function, S2F, is string to float. So it takes as an argument a string type, which in our case is Tmax underscore S. It takes that string and it converts it to a float and it stores it in Tmax. So same thing down here, string to float for Tmin. Tmin underscore S, that's a string. The function converts it to a float and it saves that as Tmin. So Tmax and Tmin, those are float types. Tmax underscore S and Tmin underscore S, those are string types. So this does the conversion. Now you may guess that there are many other similar functions for the conversions, and you'd be right. So if you wanted to convert, string to an integer, there's S to I. If you wanted a string to a double, there's S to D, and so on. So you have a whole library of these conversion functions. The reason we have to do this, is because we can't really compute with strings. We want to actually see the numbers. But when you do a get line returns a string. So we have to process the string, and then if we want to do some computations with the numbers, then we have to convert those strings to a number type in order to do the calculations. Now in this case, we're not doing any calculations. We're just using this in an if statement. But regardless, in the future, when you are doing this kind of processing, then remember that you have these conversion functions available that allow you to convert types. And I might as well include here, if you have a float or an int or any other kind of number, you can convert those numbers to string types as well. And we'll look at that in an example in the future. Where was I? Oh, okay. Now, we need to test these to make sure that these are good values for Tmax and Tmin. So let's put an if statement here to do that. Now let's look at the code. And I put a comment here. So if you wanted to convert a string to an integer, then you can use the s to I function. And if you want to convert a string to double, then you could use s to d. And as I said, you can convert to unsigned integers and other kind of things as well. All right, now for the kind of the end of our program, we want to test for these bad data flags. And if it's good data, we want to write it out to this new file that we're creating. So we have Tmax and we have Tmin, and those are those are float values already. So let's look at this if statement. So if either one of those happens to be negative 99.99, then we do not want to write the data to the out file. We want to find data records that have both good data for Tmax and Tmin. So we're saying if Tmax is not equal to this bad data flag and Tmin is not equal to that bad data flag, that means that that's a good data record. Both the Tmax and Tmin values have a legitimate number, not a bad data flag. In that case, we want to write that out to the data line. We want to write it out to our new out file. We want to write data line to the new out file. And if it isn't, we just, let's count it. So this will be the number of bad records, the records that have bad data flags for Tmax and Tmin. Now, when that is the end of the while loop, okay? So this is the complete while loop that we need for that. So it's not very long. Afterwards, after we've processed all of these data lines, then we'll have created this new data file and we've counted a number of bad records. So then we can exit the loop, we can close the input file, we can close the output file, and then let's print out that we've created a new file with the bad records filtered out. Well, I don't see anywhere that I've written out the bad records, so let's add a cout statement to that. So let's add just one line of code here, and we'll print out that there were, whatever the bad records were, filtered out. So we'll see how many of those records were actually good and how many of them were not. And that completes the program. So now we just terminate the program down here, and we do our return, and we're done. So now let's see if this works. Now we have the output. So we had the preliminary information that we got when we were reading in the first two lines. Then at the bottom, we did create a new file. That's good to know. And it's amazing that there were over 6,000 records in the file that had bad data for Tmax and Tmin. That's a huge amount. In fact, that's about 2/3 of all of the data records that we had to begin with. Well, let's go examine our new file and let's see what we have there. So I've opened up the data file. Let's bring it over. And again, it's got quite a few characters per line. So this new one, see, this is filtered Alabama weather station.txt. That's the new file that we created. We have the first line that I just wrote back to the new file. We have the underscores or the dashes. And then we have all the data records. Now, if we look over here at Tmax and Tmin, then you'll find that all of these lines have numbers that represent temperatures, and they are not bad data. Okay, the other things are the columns that we're not concerned about right now. Other columns have the bad data flag, but the Tmax and Tmin values, those are all good. So as we scroll down, then you can see we have filtered out all of those data records that had bad data for the Tmax and Tmin values. So now, if this were a real case, then we have a data file in which we have good data for Tmax, Tmin, and then we can proceed to do whatever we wanted to with that data. This gives you then an idea of how you can work with a large data file that has a somewhat complex data record structure. One advantage to this is that it is a text file, and text files are always easy to work with. Binary files, they can be quite complex, and you may need even some special software to read them. But I think we have proved the point here, so let's stop this video at this point.